So end semester exam is on May 21st, 2019. Syllabus is two-port network. This is of 30 marks, right? A1 NKN from 10 to 12, right? And two-port network, then synthesis of LC, RC, RL, and of course the realizability and PRF and filter, right? Is there anything which is left? No, then okay. So what we can do? Okay, something like question 2, question 3, question 4, RCRL maybe around 12 marks, right? Because it was major chunk. This was already asked in previous. So 8. Let's keep maybe one question, 3 marker. 11, 12. So how much is left? 7. 7. So 7 mark. Is it fine? Okay. So this is how we are going to distribute. Okay. So more or less, you understand now how I am setting the question paper. Please write what you know. Okay. So that I can see how you are approaching the questions. Sometimes your approach is correct, answer is wrong, still you can get the marks. Okay, so I want to see your creativity, how you are approaching the question, right? No bonus, it's not required right now. Right? Okay, so my main agenda is like total marks, at least somebody should get higher than 90 so that I can give O to him or her, right? So that's why I give some bonus marks. So right now it's out of 56, 53, somebody has reached, right? She or he can reach even 90 so that O can be given. It looks good also. Right? If numbers are there, then it looks good. My checking is very simple. It's liberal. You know this, right? Anyway, so we were talking about filters, and in filter, we learned that there might be first order, second order, or various orders of filter depending on how many number of elements are there in your system. So if those elements are inductor and capacitors, so I am talking about effective number of inductors and capacitors will tell you the number of poles or the order of the system. And remember, all the numerator entries has to be like, if this is n, then it might be n or maybe n plus 1. If numerator is higher than denominator, it's not possible to synthesize, at least in op-amp circuits, right? But still, it's not universal statement. I should say that there are two kinds of filters are there. Just I am telling you this theory you are going to study if you are going to study DSP. If you are interested in digital signal processing, this will be useful. So there are two kinds of filters are available generally. One is called infinite impulse response, and one is called finite impulse response. In short form, we call it IIR filter and FIR filter. IIR filter are the one which has more number of poles. Number of poles are more than number of zeros, or sometimes only poles. But if you have just zeros or more number of zeros than poles, then you can make that finite impulse response. Generally, IIR and FIR filters are the one, it's approximation. First of all, these are the mathematical functions which you are going to study, and through these functions you will design some of the filters which might be analog, which might be digital. This is applicable to both. However, in your syllabus there is nothing like analog signal processing, so I am saying that you are going to study this in digital signal processing. So for that you should be very good at signals and system and some part of network theory. Then you can get good marks or good control over DSP course. That course is generally available in next semester itself for you people. Right? You can take that course. It's a good course. Right? So you understand this. IAR has poles, more number of poles, and what generally we are studying or we want to realize in op-amp is generally IAR. We don't study about FIR generally. That's why I'm saying that number of poles will be higher. At least in the course, like next two lectures, we are not going to have any transfer function which will have more number of zeros. Okay. So before that, although these are things already known to you, but still it's worth to talk about it. You know about this one, inductor and capacitor in parallel. So do you know what is the driving point function? If I'm looking into the system, if this is L and this is C, very quickly can somebody tell me? Tell me the final equation. What is the Z of S? Yeah, Swarna. So Ls times 1 by Cs plus Ls plus 1 by Cs, right? In your school you must have studied, if I'm not wrong. SL upon, right? So how many zeros are there in the system? 1 0 and 2 poles, right? Similarly, if I want to draw two things from here, if I want to draw the AC response, when I'm saying AC response, it's combination of magnitude as well as phase. So can you draw magnitude and phase response? Okay, so you got the new specs, huh? Now can you draw on board? Yeah, Dhruv, you have to come to board and you have to draw that magnitude response and phase response, please. Yeah, whatever. I don't know. I taught you whatever I'm supposed to taught, right? Yeah, you come here, like we'll help you. So generally, I'm calling students on board because of the feedback I got from you people. If you can understand, I looked at your feedback very seriously, and I'm calling everyone. Like this is what somebody has wrote. It has to be interactive. Students should come to board and write, and so I like that idea. But was that useful or not? Yeah, okay. Okay. There is no need to solve all these things. Just draw. Okay. Only drawing. Remember, do not forget uh, to mark the axis. Just for your information, is there anybody who draws arrow like this? Are you drawing this way or this way? If you are drawing this way, please do not draw this way. It's not engineering arrow. We have to use only this arrow. You must have done in your engineering graphics course, right? Somewhere. Only use engineering arrows. Okay. Okay. Magnitude plot will have magnitude in dB with respect to frequency. Might be in radian per second or might be in hertz. Right. So you cannot forget Bode plot.
सर 0 की -20 डेसिबल होती थी ना.
0 is plus 20 dB per decade. So 0, 1 0 will contribute plus 20 dB per decade. and one pole will contribute minus 20 dB per decade, and here phase wise it's 0 to plus 90 degree, and this is 0 to minus 90 degree. Just this is just for your information. If just pole available at origin or 0 available at origin, then it's not 0 to 90 but it's 90 degree. Right. So you have to mark the values also, like the pole frequency is 1 by LC, right? Yeah, so 1 by LC, 1 by root LC. Yeah, okay. So there are two poles available at same frequency, so it's 1 by root LC. His plot is correct or wrong? Okay. You have to mark the axis, okay. And what is the value in between?
This sir,
Yeah,
J by root LC.
1 by root LC, okay.
1 by
Okay. Okay, fine. This is correct. Phase plot doesn't look like correct, huh? Look, the first is 0, so it's 90 degree minus 10 inverse. So you have to write other things here. Can you write down the phase equation? Okay, those who forgot how to, okay. So write down the phase equation there. Write down the phase equation. Use your complex number, all the fundamentals which you have studied in your school. By the way, even though I'm not writing here, but filter is can be evaluated only with Bode plot, right? So Bode plot can be asked indirectly. Transient response can be asked indirectly. All these are the response. I forgot to add one thing here. Where is it? Let's forget about this one. Okay, so please. So practice once like spice netlist. Okay, I'll give you one circuit and you have to write the netlist. Where is it? Yeah. If you have any doubt, Ujjwal. Hmm. Yes, Anish. So we are drawing only for positive axis. Otherwise, at negative axis, its same thing is available. By the way, okay. We are taking care of only causal systems. Hmm? On the y-axis is magnitude in decibel. Yeah. Okay. Just help me. Okay. So now Dhruv will write down the magnitude and phase equation for this one. You studied this one?
Sir,
Yes?
tan
Okay.
inverse B by A.
Tan inverse
B by A.
B by A. Okay, excellent. Now let's replace that with this equation 1 plus LC S square. Okay, for you to make things easier, let's replace S with j omega LC. So now write down the phase equation. What is the phase equation?
Tan inverse
Tan inverse
omega LC.
omega LC. Excellent. But if somebody will make this 1 by 10, 1 by 1 plus j omega LC, then what will happen?
1 minus.
It's minus. So it's similar to what we had here, but it's only one pole. But if it is like this, what will happen? Replace
2 times.
not 2 times. It's equal to 1 plus, what will be the value?
5. We are not
Minus
5.
omega square LC.
Okay.
Now write down the phase equation. It's 1 by, so it will be minus tan inverse.
Uh,
I'm waiting for you to answer.
root LC.
By root LC. So there are two things, imaginary and real part.
Yes.
So
This
add
one
that.
is real. 0. This is real.
Hmm?
This is real.
0 divided by 1 minus omega square LC. Is it the thing?
Yes.
Okay. Is it correct or wrong?
सीधा आएगा सर real.
Yeah, so I'm following just equation. You studied this. I'm keeping those things. Okay, you can sit down. So please follow these things, right? Those complex number and other things. If you're forgetting, it's not a good practice. Okay, so this is just for fun. We kept one Bode plot session, but there are two poles, and in your school time you must have studied such kind of thing that at 1 by root L1 C1 this response is infinite, right? This is an asymptotic line where it tends to infinity, right? Rest of the places it's smaller value, and then depending on what the transfer function is. So this is what you must have studied. Some people are drawing like this also, right? Where this peak is infinity, right? Okay. Now, in reality, if you remember in last spice session, when you were adding in spice session where you wanted to make the real system where all the parasitics will be there. So in inductor or in capacitor, you may have extra resistance, because we always believe that it's purely inductive or purely capacitive circuit, but that's not the fact. You may have some extra resistance, might be in series or might be in parallel. In inductor it goes in series, in capacitor it goes in parallel. So it has been modeled that your L and C combination has some extra resistance which is in parallel. So this is not added by us, it's parasitic, and that's the fact. It's going to happen every time. So that kind of LC, by the way, this LC is known as tank circuit. You heard about this word, Gaurav? No? Okay. Like, so both are kind of tank, L and C. One is keeping current and one is keeping voltage, right? And they are exchanging with each other, right? When you are giving the input, so that is happening. That's why in general all people are calling this circuit as a tank circuit. So if it is ideal tank circuit, you should not keep resistance. If it is lossy tank circuit, then you have to add one extra parasitic, and when you are adding that altogether, you will get some extra equation where you will have some real part also. Do you want me to solve this, or you can solve this, right? Just three elements are in parallel. Then you can find out that in denominator you will have two poles. Number of poles will not be increasing, but the location will be changed as you are changing the resistance value. So this is what kept here, that in imaginary part there is some extra resistance is coming here, and because of that you can keep this particular response as follows. If you remember, when we have started the Bode plot, we have studied different class of Bode plots. So this is going to happen if your pole is like 1 by s plus 2, no problem. But if your pole is something like this, then problem will start, because it's complex and conjugate poles or zeros are going to be look like this one. At the value of, you can say, if you are keeping q as equal to 1 by root 2, it looks like this one. As you are increasing q till this point, it will give you the higher value. So although you didn't want to amplify the signal with just inductor and capacitor in series, parallel, or the position where you are going to get the highest amplitude, it will give you V out higher than V in. This is what you can see here in the plot. Magnitude plot is V out divided by V in. So you can see that if you are going away from this particular frequency, and if your Q factor, which is quality factor, if it is higher than 1 by root 2, this overshoot will happen, or this is called underdamped system, right? So this is what going to happen, and that can be controlled by a resistance in parallel, right? This is what we want to understand, that inductor and capacitor can give you some extra shoot up. However, if this system is first order, if there is only one capacitor or one inductor, you will never see such overshoot, because it's a first order system. This will only happen if you have higher number, like s square, s raised to 4, s raised to, because as I told you, if it is complex and conjugate pairs of poles and zeros are happening, then you will have some extra overshoot, right? This is the theory we already studied in Bode plot. Okay, now let's go in different way. Rather than going into like LC parallel, we can keep LC series, right? L is here and C is here. I'm keeping one extra resistance here. This is right now not a parasitic. I kept it intentionally, right? If you are doing this, can you write down the equation? Somebody can help me in writing down V out by V in very quickly in terms of Laplace operator. Yeah, Aishwarya. Okay. You have the final equation? Yeah, tell me. What? R plus SL 1 divided by R S square LC plus SL. Okay. Right. So there are two poles and one zero, similar to what we were doing in this parallel tank. Parallel tank also giving you one zero and two poles, but here the locations are different. Both are second order filter, both are second order filter, both are low pass. The only difference is here extra resistance is added, And through the resistance you can control something called quality factor. This is one thing. One more thing we can do. There are two kinds of things we need to understand when you are in filter theory. If this is the output, or you may have this kind of output, after this frequency one plot is going with minus 20 dB per decade, one guy is going with minus 40 dB per decade. So do you understand the difference between two? First one is first order and second one is second order. And after this point this is happening. So this, in general, this particular thing is known as roll off. So one plot is roll off with minus 20 dB per decade, one guy is rolling off with minus 40 dB per decade, and this side is known as pass band. Sometimes you are going to make a circuit which is having such kind of response. Means you will have some extra zeros afterwards so that it will become flat. So then you are going to call this particular part of the magnitude response as stop band. And all these things are depending on one fact, that if my system has complex and conjugate pairs, and if it is like this, then the roll off will change. You can see black line and blue line are not exactly coinciding each other. It might be different, or it might be like this also. So the roll off will be changed if your poles and zeros are not kept at the position where you want. First thing is, if it is second order system and if those poles and zeros are complex and conjugate. Then this will happen. So to avoid that, maybe you can avoid LNC, but without LNC you cannot have any like order of the system cannot be created, right? So if those values have been taken poorly, then you may have such kind of overshoot, and which is not desirable, right? Those who are studying maybe control, you must have this over damping, under damping systems, right? So that is happening only when you have inductor and capacitor. Means you must be using mass damper spring. What are you studying? Mass damper spring, control theory. Are you studying control theory? No, you don't study mass damper and spring, something like this. Oh, so mass damper spring is similar to RLC circuit. Exactly, it's an analogy between mechanical system and our electrical system. Okay, so that is what I'm saying. So if you are, generally we are electrical engineer, and if your professor who is teaching you control, if he is also electrical engineer, then he is going to convert this to electrical system and then solve everything. If he is doing that, then you will end up with similar circuit here. It's same as mechanical system, which is known as mass damper spring, and this is RLC. All are actually connected with each other when you are converting from mechanical to electrical. Have you studied this mechanical to electrical, electrical to mechanical?
Actually, LC circuit is similar to without damping spring
Yeah.
mass system. R
Yeah.
if there is a loss then.
Okay. So it's a similar thing what I want to tell you here. Right? Now, if you are swapping between inductor and capacitor, if you are swapping between inductor and capacitor, there might be the case that this will become, again, it's a second order, because there are two different like two different frequency dependent elements are there. One zero is also there, but here you can see that it's two zeros and two poles. So now it's all depending on how you are choosing the value of R, L and C. This might be high pass or this might be low pass. It depending on RLC values. Right? So here in this case, if you are drawing and if you, it will be minus 40 dB per decade at the beginning, and thereafter there are two zeros, two poles like this. So this will give you high pass characteristic, right? But still you can change with RLC values. Still it's in your hand. Maybe we have seen such system maybe earlier where you are choosing the R and C value. By tuning that, you could have changed low pass to high pass and high pass to low pass. Okay, and this, like all these things will give you different response. So if you have two elements, it's second order. That's one thing. If inductor and capacitor are here, what kind of response you are going to see, by the way? By just observation, can you tell me which kind of filter it will be? Akshat? Yeah. So we have four different possibilities. One is low pass, high pass, band pass and notch. So which one do you think it will be? So, so band pass or notch? Are you asking question or? So band pass or notch? Look, okay, those who are not aware of the technique, generally if such kind of question is given to you, then at zero frequency, what is happening to capacitor? Open or short? Open. Okay. And inductor, it is short. So it's a, as it is short circuit, V out will not be equal to V in, but it's directly connected to zero, right? Because zero resistance path will flow. So V out equal to zero. At high frequency, this is short circuit and this is open. So V out is again zero. So V out is again zero at low frequency and high frequency. So what is happening in between? In between, when both are, there might be the case that both will be off. There will be one possibility that both will be off. Then you will see V out equal to V in. If both are off. But there will be one at one frequency, this will happen. And that is known as resonance frequency. You can find out, right? By equating that to zero, right? So this is possible. So now tell me what kind of response it is. Band pass. Now if I want to create notch filter, then how can you make notch filter? Just RLC with RLC circuit. Okay, so this one you are saying in parallel, is it like this? By the way, this is not not a unique solution. There might be many solutions, right? You can make other way also if you want, right? So this will give you notch. Again, so you are using the parallel LC tank and other side. Okay, now so I believe this was just a recap what you studied in your school time, right? So series parallel LC circuits and the tank response which we have studied. And if there are only two components, then it will be second order system. So now let's assume that there are two scientists came, Selen and Key. So that's why they are in capital. And they found out that there is one approach through which, like they gave this circuit, that this is the circuit, you use it, and it is a second order system. The good part of this particular design is there are two resistances and two capacitors. Look at all these people, Selenki and other, if we are going to study, all these were actually targeting the system for the mobile application. Means they want to make things in a small chip. So if you want to make something in a chip or on chip, we are going to avoid inductor, because inductor is going to take more area, and to make that you have to make that spiral thing. So we are going to avoid it, and that's what these two people told us. Without inductor, I'll give you second order performance by two capacitors. So now can we try to solve this? Is there any? Let's see how much good are you at op amp if the system is little bit different than what you have studied. Let's try to solve this. Okay, R1. Right now, treat this op amp uh, as an ideal op amp which has infinite gain, and you can apply the golden rules. So what golden rules tells you, Anvesh? So not V out equal to V in, V plus is equal to V minus, and no current flows inside op amp, or right, no current flow inside. Okay, no current inside, outside, whatever. So this is just triangle, right? This is only happening when the gain of this amplifier is infinite, and if nothing is written, means A equal to infinity. So you can apply these two rules. Now can you solve this using RLC or sorry, KCL, KVL, or whatever law you know? So V out, if this is V out, what will be plus terminal? V out. Okay. This positive is coming back, yeah. This is negative feedback. This is negative feedback. So this topology has been given by Selen and Key. This is very standard design. So let's see how you are using KCL, KVL. Let's call this point as some point called Vx. So what approach are you doing? Dinesh, can you check others what they are doing? If you need any help, you can ask me. So are you going to write down 2-3 equations? How many equations are you going to write down? Because I can solve in one equation, by the way. Yeah, okay. How do you find out one equation only? Current at that node. Excellent. At this node, because it covers all the nodes. At Vx, can you write down the KCL and tell me what is happening? So all the current which are outgoing, that is what needs to be taken care. Now tell me. Vx minus V in divided by R1 plus Vx minus V out divided by, no, okay, you are taking that one first. Okay, R2 plus Vx minus V out divided by 1 by C1s equal to 0. Right? Now you need to find out what is happening at this point. Look, there is no current is flowing inside op amp, so the current through R1 and C2 will be exactly same. So can you find out this current now? If both are same, Vaibhav, are you following? So if both are same, then what will be the value of the current? Not Vx here. Look, if you need to find out, okay, before going to anything, let's assume that there is a circuit like this. if I want to find out the current flowing through R, and if both the currents are exactly same, then I am not going to calculate anything between here like Vy minus Vx divided by R. That's the current. That will not give you any answer. But if you are looking at this, Vx minus 0 divided by 1 by Cs. So Vx times Cs, that's the current flowing through here and here also. So can you apply same thing here? The current flowing through this resistance is same as C2. That will be equal to V out times C2S. C2S. And I know that Vx is nothing but V out, because you can see that it's a KVL I can apply. Vx is equal to V out plus V out times C2S R2. Now Vx is already available to you in terms of V out. Keep that one here and find out V out in terms of V in and find out transfer function. Can you do that? If there are some plus minus mistake, please correct it. Okay. Yeah, Mahima, following this is fine. Swarna, you got the answer? V out by V in. Okay. So what is V out by V in? Just arranging terms here and there, and then you will get the answer. To solve op-amp, just you need KCL or KVL and these two golden rule equations, right? Look, I might ask you, I'll give you a hint. I might ask you to solve, such kind of network using op-amp. In filter, maybe I'm not asking anything else. I'm just asking you to draw, find out V out by V in, right? So are they doing correct, Dinesh? Okay, those who have done it, can you try this one? Different kind of can you try this one? Those who have completed the first one, then can you try this one? So now V out will be changed. That is the only thing. So now can you see we don't need three equations. If I remember correctly, people were writing three equations, four equations, right? In first exam, you have to use the optimized one or two equations and it will work. You don't need to write down equation at input side or output side in most of the cases. So the remaining node will give you answer. Yeah, Divanshu, is it fine? Okay. Are you seeing this answer similar to? Yeah. So can you add two resistance and find out if this is R3 and R4? What is the transfer function in such equation? Yeah. Okay. Modified one. Okay. This equations will be same. V out will be changed. V out will be some weighted value from here. But V plus equal to V minus. So whatever earlier we were reaching here V out value, but here it will not be V out, but it might be some value called Vy, and this is Vy. So can you find out Vy in terms of V out now?
So that means that
Yeah.
like the current is flowing from that VY node to ground or somewhere because it is at higher potential.
Yeah, so of course it can flow.
So that means op amp like current is flowing outside the op amp.
Of
But
course,
we assume that current is
actually
not
op amp has very high input impedance. It's like this. That's why no current can flow inside. That is the main reason. If you study when op amp has high input impedance, so current cannot go inside.
मतलब सर
Hmm.
एक अंदर जा सकता है और बाहर नहीं जा सकता मतलब
बाहर
अंदर नहीं जा सकता और बाहर आ सकता है करंट
look, of course, it has to drive something to tell that there is no current flowing outside. That's a wrong statement. But
I'm asking that
okay,
we assume that op amp does not it has high input impedance that means no current can flow inside and outside also of the op amp.
so if you are asking me that the current will flow this way, no, it will not go inside. Similarly,
But
this way, no.
if I ask that current is moving away from like the direction is just opposite what you have shown just now.
So it's because of there is some load which is asking for current. Look, there are so many branches are there. Those who are asking for current, right? You are connecting here some V in with respect to ground. It will ask for some current. You are connecting here some load. So all will ask for current, but the op amp will not ask for some current in ideal condition.
Sir, if they remove capacitance, C1,
Yeah.
then means they are making it a buffer.
Yeah, then it's a
So there will be there is a chance of current to pass through.
no. In any case, if it is ideal op amp, there is no current passing in and out. But if you want to see the real current, then you have to understand the real working of op amp, right? So that's a different thing. Hmm?
Then negative what will happen at the negative side that's the reason.
Which negative side? This side.
Yeah
What voltage is coming here, or what
like
current?
current direction.
Current direction. Of course, it will go towards zero side, right? It will go this side. It will never go upside, right? It will try to reach zero.
But then V out like that is a V out and between R3 and R4
Yes.
that potential will be
Yeah.
current will go on right side.
Yeah.
Between the node between R3 and R4 it is V out.
R3 and R4. Yes, this is V out.
So like
So V.
can we say that Vy is always at a higher potential than V out or either equal or higher?
Yes, correct. But this will only. It depends on R3 and R4 value. So can you tell me what is V out in terms of Vy? You agree with this? If this ratio is less than 1, then Vy is lesser than V out. Anvesh.
So, but if Vy is lesser than V out, then there will always be a tendency that current will try to flow inside the op. Because
Yeah, that's the. I'm telling you that is possible thing if this op amp is not ideal, right? As long as you are saying that it is ideal, nothing will go here and there. But that will happen at the higher level. Study this next level. Like I am teaching CMOS analog IC design. I am teaching only this triangle. What is inside that? Okay. And every day we are going to study that current is going inside also and outside also. Right? I'm teaching only op amp. The- हाँ
सर अगर आगे लोड लगा देते हैं
हम्म
करंट जो ग्राउंड में जा रहा है वो आगे भी जाएगा
आगे भी जाएगा. It will be going there. Of course. It will follow KCL. I'm restrict the current only for this op amp.
अभी जो है V out है open है
V out, yeah, it's not actually open, but it's connected from a system, right, where the input impedance is very high. If you are connecting this V out to oscilloscope, it's equal to 1 mega ohm. It's equal to 1 mega ohm, which I am going to consider as infinity, and that's why it's looks like open. Otherwise, V out cannot be open ever, right?
That means current is not flowing into the, like, from here also,
Yeah.
from node Vx. Vx, no current is flowing into the capacitor.
Okay. Okay. So tell me, what kind of filter it is?
It's high pass,
High pass. How did you find out it's high pass?
because
At omega equal to 0, what is happening?
at low frequency it was short.
Short. Okay. But what is happening at infinity? Now tell me, it V out is exactly equal to V in or something else?
Something else.
How did you find out that something else?
Some current will be flowing.
Yeah, so it's depending on the input resistance of measuring instrument, right? So V out is equal to, right? So if this is some low value, then of course it will be divided between two resistance. And sometimes similar thing you are seeing, which is known as loading effect. But if it is infinity, then there is no problem, right? Yes or no? Because otherwise this is,
My basic doubt was that current can flow out of the op amp, that we can.
of course, but it's not because of op amp,
Yeah, it's because of the.
because of load. That is what I'm saying. Somebody else who is asking for current, that might be load, that might be this V in, it might be capacitor, resistance, everyone. But in ideal condition, what we are learning right now, that op amp will not have any input current or not have any output current. This is a big assumption. Look, so a few years back, I was teaching some electrical workshop to chemical chemistry people, MSc chemistry. So they were saying that in that case, we can remove this entire triangle. Why are you keeping here? Yeah. So we are doing this because otherwise it's very difficult to analyze such system. That is the thing. To analyze it and to get the answer very quickly, we are doing this with some assumptions. Okay. Okay. Very quickly, I'll. Okay. It's possible. It's not possible to cover it now. Just for like information, there are many people who know about this thing, but there are, like, by inspired from your question, I'm telling you something which should be known to you, if, to answer your question actually, right? This is G is known as forward gain and H is known as feedback gain. So if this is out and if this is in, can we write down out divided by in? Okay. G divided by 1 plus GH. So generally this is going to happen in every negative feedback system, which will have forward gain and some feedback gain. Now the problem is, in this forward gain you may have such system, right? If you are designing this forward gain using an amplifier which is made up of BJT or maybe MOSFET, So there are few things I would like to tell you. Do you remember IC is equal to beta IB? And you must have also know that beta varies from something like 100 to 300. So how much difference you can see? Like sometimes like 100 times, sometimes 300 times base current you are going to see in open loop condition. So I don't like any amplifier which is going to behave very vastly like 100 to 300. If I'm using it in India, it will be different. In Finland, it's different. I don't like such system. So I want to make it in closed loop, and I want that my output divided by input, which is the gain, in closed loop should not depend on the gain of G but depending only on H. This is only possible when gain is sufficiently large, or which I am going to call it infinity, then it's equal to so this is only possible when this is infinite. And for every condition which we are going to call it PVT, process voltage and temperature, for any temperature, any voltage, or any company who is making such circuit, still my PVT closed loop gain should be 1 by H only, means depending only on feedback, not on open loop forward gain. And that is what we are doing here. So at the end, the transfer function which we are seeing is not depending on internal structure of your op amp, but this op amp make sure that this transfer function will be PVT independent, or for any process, any voltage or any temperature, it should not change. You understand, Divanshu? So that's the main crux of the story. If it is not there, then this gain will also come into the picture. This, if you study somewhere like op amp, it might be second order, third order, fourth order system, and that will actually affect this performance also. And that in real transfer function, it's G over 1 plus GH, and you have to write that. So as a designer, we have to make sure that this op amp should have enough gain, right? Does it answer your question? I don't know. I'm trying to answer at this level. But are you following?
What is H in case of
Hmm? H in case of op amp. Yeah, it's there sometimes. We are keeping that also. We are going to study that next. In case feedback, we are going to keep op amp also. But does it answer? At least, I don't know. At this level, can I answer completely or not?